Okay, good afternoon. Thank you for coming here. I know it's kind of late in the day, so I appreciate you being here. So what I'll be talking about is what is the next thing after LLMs? Or what do I believe the next thing is after LLMs? And I think it's something that called cognitive AI. I'll talk about the limitations of LLMs and whether we think they can be overcome potentially. And then I'll switch over and talk about AGI, what AGI is, and how perhaps we can get to AGI. And I'll finish off by summarizing why I think we don't have AGI. Obviously, the implication here is that I think maybe we should already have it. So what I'm talking about is not a $7 trillion requirement. It's basically an approach that will take a tiny fraction of the cost and time to train and to run. Because it can be trained incrementally in real time, which is an important requirement, it doesn't hallucinate, and it's auditable, at least to a much greater extent than LLMs are. So what is this? DARPA have, a few years ago, they came up with this model of the 3 waves of AI. And what they mean by that, the first wave is basically what's now referred to as good old-fashioned AI. So those were basically logic approaches, expert systems and things like that. And then, of course, the second wave hit us like a tsunami about 12 years ago or so. And that's all about deep learning, machine learning, statistical approaches. And that's a wave we're riding right now. And it's obviously a hell of a ride. Now, the third wave is what DARPA described as an adaptive agent-based cognitive system. And we refer to it as cognitive AI. So the starting point for cognitive AI is you really start with understanding what intelligence entails, or specifically, what kind of intelligence are we looking for in AI? What is important to us? And what makes human intelligence so special? Because that's the part we want to automate. So human intelligence is unique in that we can learn and reason conceptually. We can form concepts, we can form abstractions on top of abstractions on top of abstractions in real time as we understand things. We interact with the environment, we interact internally, even if we're not talking to somebody, if we're reading something, we kind of interact with our own internal processes, with our metacognition. And of course, our understanding is grounded in real experience. And we have what Daniel Kahneman calls the system 2, metacognition, or thinking about thinking, the ability to monitor our thought process, our mental processes. So another very key point that is often misunderstood or misrepresented is that intelligence isn't fundamentally about having knowledge and skills. It's about the ability to acquire knowledge and skills. So, if as an adult you have a whole bunch of knowledge and skills, there's a subset of skills that you have that are learning skills that enable you to acquire more knowledge and skills. And that's really the key to intelligence. So you kind of bootstrap yourself. You can have a smart 10-year-old that may know very little about anything, but has the ability to learn and acquire knowledge. So this actually kind of also brings us back to the original dream of AI. When the term AI was coined some 70 years ago, it was about building thinking machines that can think, learn, and reason the way humans do. They thought this could be cracked in like 6 months or a year. Well, of course, it turned out to be much, much, much harder. So what happened over the decades is that AI turned into essentially a narrow AI. And it hasn't been about building machines that have the intelligence internally, but more that you have external intelligence, the intelligence of the programmer or the data scientist, that uses computers to achieve things that we consider intelligent. But what we really want is we want the intelligence to be in the machine, that it can learn largely by itself. So this matrix here kind of, lays it out. You want a system that is fully autonomous and fully adaptive. So it can adjust to new circumstances in real time, on the fly, and it can do that largely by itself. Now, when I say largely by itself, of course, humans are also very good tool users. So if it needs help or something else, even a ChatGPT, or some database, or another human, or whatever, another AI, it can obviously get that help, but it's motivated by its own understanding of its knowledge and its lack of knowledge or its lack of understanding. So in summary, what is cognitive AI? It starts with understanding what intelligence requires, and that is to be adaptive in real time and conceptual in its ability to learn and largely autonomous. And this here is a picture I'll go into this in a bit more detail later on, but this is a very abstract diagram of a cognitive architecture that we've implemented, which essentially is a very, very high performance knowledge graph. It's literally 1,000 times faster than any graph database that has all of the learning mechanisms and inference mechanisms and so on fully integrated with this knowledge representation. So let's talk about LLMs because obviously tons of money are flowing into LLMs. And if we could somehow coax LLMs into being adaptive and overcoming the problems that it has, could we not then get the kind of intelligence that we want? So I think that already the name suggests some of the intractable problems. GPT, generative, it makes up stuff. It's trained on massive amounts of data, good, bad, and ugly. And it doesn't really know what's good, bad, and ugly. So it basically just statistically, in a very, very sophisticated manner, produces output from that. So it's generative. P, it's pre-trained. It's trained at the factory, $100 million, I don't know how many weeks or months to train it. And it's essentially a read-only system. The core model cannot be updated as it's interacting with the world. And the T, of course, stands for transformers. And that as long as we're working with transformers, and all indications are that transformers is where it's happening, or variations of them, we are really tied to kind of backpropagation, bulk training. So it kind of locks us into this pre-trained model. So, the limitations that we experience in them, of course, hallucinations, it's unpredictable. It really needs a human in the loop. And we're seeing that my company automates call centers with the technology that we have, cognitive AI. And as we talk to our customers and potential customers, a lot of them, well, not a lot, all of them have played with large language models in the last year. In fact, invested a lot of effort to try and get large language models to work. And they're all coming to the conclusion that they cannot use it for anything that's critical, that doesn't have a human in the loop, or where it's not critical. Like an FAQ, okay, if it shows up the wrong answer in an FAQ, it's not the end of the world. But you can't have it for critical things that might update your database. Have to apply complex rules, business rules, and so on reliably. The inability to learn in real time, of course, a difficulty in training, and I'll talk a little bit more about that. And if you try to do additional training, you run into catastrophic forgetting, which is, another kind of unpredictable byproduct. It's a black box, so auditors and lawyers, the legal teams aren't very happy about implementing them because you really, if it goes wrong, all you can really do is retrain it, tweak it in some way, but you're not sure that it's not going to do something else really bad. Like I mentioned at the panel this morning, like the Chevrolet dealer that had a chatbot and it ended up selling a car for $1, brand new car for $1. And the ChatGPT was very happy to confirm, yes, this is a legal transaction. So, of course, dealer was not too happy with it. And there are many other examples like that. yeah, it doesn't know what it's doing. It doesn't know what it's thinking. There's no metacognition. And it is extremely expensive. In fact, I was just having a conversation over lunch that, you know, ChatGPT 4 is so expensive to run that by itself is a barrier for implementation. And I mean, I know I've tried to run some simple experiments that cost me nothing, I mean, pennies on cognitive AI. It was like, before I knew it was $200 gone for just like a simple batch test that I ran. So it is expensive, not just to train, but also to run. And the other problem, that running out of data. So they're diminishing returns in building bigger and bigger models. So having a model that's 10 times bigger and 10 times more expensive is not going to give you 10 times more performance. So I had a meeting here a few weeks ago at a regular meetup that we have, and that was particularly aimed at saying, can we not overcome these limitations? Now, I'd love experts to come forward and convince me that they can be overcome, because it would be terrific if we can get to human-level AI, practical AI, through LLMs. But let's take these. So hallucinations, fine-tuning, you know, parameter tweaking, and so on. You can limit that, but the more you limit it, the more you dumb down the system as well. And you get to a point where it's sort of tail wagging the dog, where all of the outside code and stuff that you've written to try and make the thing tractable negates the power of the LLM to a large extent. And you can't get rid of hallucinations except if you totally cripple it. Of course, there are things you can do, but they're not easy, and ultimately they're not really going to solve the problem. Now, real-time learning, there are really two mechanisms that are proposed here. The one is having a larger context window. But there are problems with that. Whatever goes into your context window isn't really integrated. It isn't the knowledge isn't assembled in any meaningful way. And you know, as people who've experimented with that, and we have as well, it basically doesn't know what to select out of that context menu. It tends to focus on, I think a recent paper showed it tends to focus on the first 15% and the last 15%, or you know, it's probably different for different types of models, but the knowledge that's in the context menu is not really organized and reliably accessible. And then, of course, the other one is RAG, but that's just an external database. You know, it does not update the model itself. So can be powerful, and you know, please don't misunderstand me. There are many applications for LLMs that are very, very useful and powerful, and people can make a lot of money with it. But if we're talking about trying to get to intelligence, we hit these limitations. Black box, yeah, not too much that can be done about that, and the expense. Again, there are lots of tweaks to reduce the cost, but on the other hand, the models are getting bigger and bigger. So yes, the limitations really largely remain. They can be mitigated to some extent, but they can't be eliminated. So it's really not fixable. So here's a comparison now between generative AI and cognitive AI. And you can see it's chalk and cheese. It's really very, very different. You're talking about training costs and running costs that are many orders of magnitude lower. You have real-time learning. You don't have confabulation. You don't need a human in the loop on if the system has been trained reliably, and it's scrutable. You can basically understand what's going wrong. Now, of course, in a complex system, when I say it's scrutable, it may still be difficult to analyze the full decision path, but at least it's possible in principle to do that. So, does that sound too good to be true? So how is this possible? As I said, we use a cognitive architecture, which is uses small data. So certainly a cognitive architecture of that nature would never compete with LLMs in the vast amount of knowledge we have. But is that really, do you really need that? You know, do you need a model that can code in 20 different computer languages and knows about all the dishes, you know, eaten in every place in the world, and, you know, cricket scores and I don't know what, you know, all the stuff that it has in the model? No, you don't really need that. And if you need it, again, it can be a tool user. It'll know that it doesn't know some information. It'll know where it can get that information, and in a much more reliable way. So it's a small data algorithm learning system that can learn incrementally. So it doesn't use back propagation. It learns incrementally. You can also, or really the inherent part of it is that it encodes ontologies. You can also import complete ontologies. So if you have a medical ontology or some specialized ontology, that can just be straight imported into the knowledge graph in the structure, and then that knowledge will be immediately accessible. You know where it goes in the knowledge graph, but it's part of the bigger system. So as I mentioned, super high performance vector graph database that we have, and we did bench tests against the state-of-the-art graph databases, and we're literally 1,000 times faster by having a custom designed system that runs totally in memory and has been optimized for this purpose. So all of the different features that you need for cognition, such as short-term memory, long-term memory, context, reasoning, natural language generation, they are all part of the core infrastructure of the system. Either they are part of what one could call nature, that are built in, but that's a very small part. Most of it has been learned. So you're starting with largely a blank slate. So similar to a child, you have basic learning mechanisms that are hard-coded, that are part of the system, but almost everything has been learned. How to reason, natural language understanding, all of that has been learned from the ground up. And of course, it's highly effective in one-shot learning, zero-shot learning. I mean, it's default mode. So, like a child, if a child has never seen a giraffe and you show it one picture of a giraffe, it'll now be able to recognize giraffes in different colors and from the side and upside down and so on. And in the same way, this is the way a cognitive architecture works. Now, we do have some proof points. One of our flagship customers is 1-800-Flowers. Last week they had Valentine's Day. We replaced 3,000 agents with full automation that we do, and providing better service than humans can do. No wait time. It has access to the individual, so you're hyper-personalized at scale, basically, for each individual. You know what they've bought, when they bought it, who they bought it for, and you can use that in the conversation and learn new information that you come across. And each customer actually has essentially his own copy of this graph database, so there's no cross-contamination. So, not $7 trillion. They're not needed, not for training, not for development, not to develop the technology. And I'll tell you a little bit later why I think we haven't got this yet at human level. So I'd like to spend a bit of time now talking about artificial general intelligence. Now, my own journey is I started working on AGI more than 25 years ago. In fact, I coined the term AGI in 2002 together with two other people, Ben Goertzel and Shane Legg. We got together to write a book on this revival of AI. How can we get back to the original dream of AI, to build thinking machines? So there were a few of us that felt the time was right to tackle this in 2002, 2001, 2002. So we decided to write a book, and the three of us decided on the book title AGI. We didn't artificial general intelligence. We didn't know that the term would catch on like it has, so that's rather nice. To me, the general, in fact, relates also to little g in psychology, which is IQ, or general intelligence. And that, to me, is kind of the important part. But what is AGI? Let's kind of get a better handle on this. So computer systems can match or exceed the real-time cognitive, not physical abilities of a smart human. I sometimes talk about this as my model of AGI is the Helen Hawking model of AGI. And what I mean by that is Helen Keller and Stephen Hawking. So Helen Keller didn't have a lot of sense acuity. She was deaf and blind. And Stephen Hawking, of course, didn't have a lot of dexterity. But they were very, very smart people. So, it gives you an idea that if we can kind of make our task a little bit easier, we don't have to deal with all the robotics. We don't have to deal with the full sense acuity of a human. There need to be some sense input to interact with the world, but not full human sense acuity. So to me, but let me explain it a few different ways, or let other people talk about it. AGI will be the most transformative invention in human history, more than fire, electricity, or internet. Absolutely. That's how big AGI is going to be. This is not AGI, so don't listen to Sam Altman. That's marketing talk or funding talk or whatever. It's nonsense. You can't say you're going to have AGI and it's not going to have a big impact. It just makes no sense. So, So, yeah, let's imagine what the world will look like with AGI. So, first of all, one of the things that I love about the idea and what motivates me is to have AGI researchers. Imagine training up a single AGI to be a cancer researcher. You now make 1 million copies of that. You have 1 million cancer researchers chipping away at the problem, pursuing different paths, communicating with each other. We're going to make progress much, much quicker. Now, you take that across, all the various problems that we want to solve, in disease, in pollution, and better battery technology or energy, many, many areas that really require more focused intelligence. And it'll have the benefits of being a computer as opposed to a human. It'll be a much lower cost than human. It'll communicate much better with other AIs than humans do. You don't have egos getting in the way and stuff like that. So it can work 24/7, full concentration, which we can't do. It won't have certain distractions that we humans tend to have. It'll have perfect memory. It'll have access to all the information in the world sort of at its fingertips and, just by thinking about it. And it'll be much better at logical thinking than we are. Logical thinking for humans is really an evolutionary afterthought. We only only barely can do it. So it'll be much better at really thinking things through rationally and not falling into a lot of the sort of logical traps that we tend to fall into. So, that's for researchers, but the same is true for really any job. I mean, immediately without robotics, you can replace any desk-bound job. And of course, you can also then get into robotics, which will be a massive reduction in cost in the cost of goods and services. It'll be a tremendous wealth creator, radical abundance by dramatically bringing down the costs of everything. The third area is really something I'm personally very, very keen on, and I call it a personal assistant. And what I mean by that is it's personal assistant that you have that's personal in 3 different ways. The first personal is you own it. It's yours. It serves your agenda, not some mega corporations. The second personal is that it's hyper-personalized to you. So it knows your history, your dreams, your preferences, your priorities, just for you. And the third personal is the issue of privacy, that you decide what you want to share with whom. So certain things you share with your spouse, other things you share with co-workers, some things you share with Amazon. So that's the kind of personal assistant that I envisage that everybody in the world should have. It'll be a bit like a little angel on your shoulder that can help you make better decisions about your life and really like a trusted friend or companion that can not only do things for you, but also help you think things through. And I think that will really help human flourishing. That's my vision of AGI, and I can't wait for it to happen. So cycling back to, where are we now? Can LLMs get us to AGI? Well, obviously, I don't think so. But I'm not the only person. In fact, if you talk to data scientists, if you talk to scientists working in the field of large language models, there's pretty broad agreement that we need something else. Now, as long as you can get more funding and so on, and make hay while the sun shines, of course, people will we'll somehow get to AGI, just give us more money and we'll chip away at it. But really, the reality of it, no, LLMs are very unlikely to get us there, even with tweaks. It has to be something fundamentally different. So I'll finish off by talking about why I think we don't have AGI yet. And really, the simplest reason is hardly anybody is working on it. And that may sound strange. You say, well, hasn't DeepMind been working on this with 600 PhD level researchers for the last, 10 years now? Well, no, they're not actually working on AGI. As Dennis Hasabe says, deep learning, machine learning is amazing technology, but it's not going to get us to AGI, not by a long shot. So they haven't actually been working on AGI. They've been working on stuff that somehow they could get traction on. And that's really true for pretty much, you look around and you ask people, do you have a plan to get to AGI? What is your plan? Are you actually working on AGI? Or are you just working on something that you hope maybe will get you there, and in the meantime, have some cool products and make some nice money? The tremendous success of statistical approaches has really sucked all of the oxygen out of the air. There's no room for any other approach. If you want to do a PhD, it's got to be deep learning, machine learning. You're not going to get a sponsor for cognitive AI. If you want to get funding, again, deep learning, machine learning. You want to get a paper published. You want to earn the big bucks. It's all about where the momentum is right now. So it's been really hard for us because I believed, and I came to the conclusion 20 years ago, that we need a cognitive architecture, that you need this real-time learning, conceptual learning, and all the things I spoke about. But that's not fashionable to work on it. So it's really hard to get any love for that. There's also a kind of an interesting thing is we now actually have like a lost generation. People who were trained in AI over the last 10, 15 years really don't even know that there is something other than statistical AI, that there's anything other than machine learning. To them, machine learning is AI. AI is machine learning. So to talk about cognitive architectures, it just draws a blank. And it used to be that people working on AI actually had an interest in how the mind works, had an interest in cognition. There's a field of cognitive science, which is the intersection of philosophy, cognitive psychology, and computer science. And that, I think, is the perspective you need. I've hired some brilliant engineers that were brilliant mathematicians, logicians. They just couldn't get their head around cognition, or what am I talking about when I'm talking about thought or concept formation or any of the sort of cognitive terms, or metacognition. Where do emotions fit in? Never mind free will and consciousness. We're happy to talk about that too. But you really need to have a deep understanding of cognition and the ability to translate it into code to be able to solve this problem. And there are very, very few people that actually are comfortable in both fields. And then, for influential people, influencers, and deep-pocketed individuals, I'm often shocked at the lack of vision they have. They might have billions of dollars that they, now want to give away or something, and they give it away to the university. Sorry. That's already sitting on, $50 billion and doesn't quite know what to do with it, and then, of course, lastly, there's skepticism and fear of AGI, potentially. There are people who really believe we shouldn't have AGI for various reasons. And, that's a legitimate discussion to have, Should we be pursuing AGI? And should you be scared of it? So this is a graph I came up with recently, again, kind of re-emphasizes the difference in approach. LLMs have massive amounts of knowledge and skills. But what we really need is real-time, autonomous, adaptive, conceptual learning and reasoning. And that's the path you need to take to get to human intelligence and beyond. And this can't get you there. And the problem is taking this route. People say, well, why can't you answer all the questions? Why can't you write me a poem? And why can't you do this? Why can't you, why don't you have all the knowledge that an LLM has? Well, no, that's not what we're concentrating on. So we can't shape on the benchmarks that everybody is chasing, But also they can't shape on the benchmarks that real intelligence requires. So, we're really at a unique moment in history where ChatGPT has been amazing. I mean, it's blown us away. It's blown me away. It's blown everybody away. I don't think anybody expected, just by scaling up, that you could get the kind of performance that seems like really deep understanding, until you try to really use it. So, it's given us this taste of AGI, this taste. It seems so close. We seem to be so close, and yet so far. I mean, look at the number, and this is out of date. I mean, billions and billions of dollars are flowing into it. So there's obviously a lot of excitement. But we see this third wave that really needs to be implemented and activated of cognitive AI, and hardly anybody is working on it. And I think that'll change. But as I say, we are at this very interesting time. So, full circle, again, cost and time of training these things is one of the real practical roadblocks now for implementing LLMs. And maybe that's the most persuasive argument. I don't know. It certainly is a very persuasive argument if you can say, instead of needing $100 million to train your model, you need $1,000 or $100 to train a model that can do useful things. That's huge. Our agents can run on a 5-year-old laptop, complete, no GPU or anything. So, I'll just end off with promoting my company a little bit. So we've been developing and perfecting proto-AGI, not at AGI level, not at human level, for more than 15 years and commercializing it. And, we believe we have the foundational technology and the team, several people that have worked on this with me for the last 7-10 years or more. So thank you. And if you are interested, there's a meetup group called AGI Beyond LLMs. We have monthly meetings here in Austin at the Capital Factory. And love to see you there, and we brainstorm it. I'd love to get a speaker who would tell me why I'm talking nonsense here about LLMs. But anyway, we talk about all different aspects of, consciousness and will AI not turn on us and those kind of very important topics. So I think we have a little bit of time for questions. Yep. All right.
So, of course, agree in the importance of AGI. And you didn't talk, though, about the cognitive AI. And so we can understand how it's different from LLMs, other than to say that it's not LLMs. It's not statistical. It's a cognitive approach. But I don't quite understand what it is. Is there a resource that...
mean, cognitive architectures, people used to know about cognitive architectures. That was a big area of research. Now, of course, the argument goes, yeah, we've tried cognitive architectures and they haven't worked. Well, go back 15 years and people said, well, we tried neural networks and they haven't worked, until somebody got them to work. So it's essentially a cognitive architecture, an architecture that's specifically designed to embody, to implement the core requirements of intelligence that I've spoken about. The ability to learn in real time. So there are algorithms that can learn in real time, that can generalize, that can do induction, and the knowledge itself, the knowledge and skills, are embedded in a high-performance vector graph database. So, that's sort of the technical detail. You have a vector graph database that's of much, much higher performance than commercially available ones. And it embodies the actual learning mechanisms and some of the reasoning mechanisms that are needed for intelligence. And then the system, from there, bootstraps itself by a curriculum that we have. In fact, in our company, about 8 of our people in the company, we call them AI psychologists. It's a profession I invented. They're basically linguists and cognitive psychologists, and their job is to come up with a curriculum to teach the system in the right sequence, language, reasoning, and basically how to bootstrap themselves and learn anything that they need to learn.
Is this related to active inferencing AI, Carl Friston's free energy principle?
No, not as far as I know. I'm struggling to get my head around exactly what they do, but this is more of a statistical system. Yeah, it's a sort of free energy. So it's, yeah, I wouldn't say so. So Intel have an active project. But it's a research project. I don't know if it'll see the light of day. Yep.
So I have been involved with the traditional AI now for 30 years, but with the different paradigms. But where do you suggest that we get more resources for getting more involved with AGI?
I wish I knew. I've been trying very hard to get people to even talk about it. It's actually quite baffling to me. There must be a lot of people who believe AGI is a positive and we should achieve it sooner rather than later. I mean, there's a perspective that maybe we need AGI to save us from ourselves. We need more intelligence. But it's been incredibly weird and frustrating for me that when I try to look for people to discuss, I've tried to put together workshops to say, we'll share our technology with you. We just want to brainstorm what is the quickest way to get to it. And if our way is not the way to do it, great. Let's share our insights. And I've had no takers. Now, is it because I don't have enough credibility, or I'm not persuasive enough, or there's a whole I'm not an academic, so there's that problem. I don't know what it is. How I've been unable to get together people who say they're interested in AGI, and then you want to, okay, can we talk about it? Can we have a workshop or something? Oh no, I'm busy starting some company implementing LLMs, and that's what I'm busy doing. I know it's not going to get us to AGI, and I really want AGI, but that's what I'm doing. It's bizarre that I've not found people who are even willing to say, hey, let's spend 2 or 3 days brainstorming this.
Yeah, a bit of a devil's advocate question. Yeah, you're saying there's these 2 paths, and like you said, traditional symbolic AI, logic, reasoning, it kind of was at the forefront in the 70s, 80s, and 90s, and then the machine learning, deep learning kind of has taken over everything, it seems. But is there a way to synthesize the 2? It seems to me that, you're saying LLMs is not the path to AGI. I would agree with that, but it feels like they are knocking down problem after problem with different innovations. And you have one on the last line, you talk about tool user. Your system could be a tool user that includes LLMs. Wouldn't that be the case? Or could you see a system that actually combines the two approaches to get the best of both worlds? That's where I'm really going.
Yeah, absolutely. So a couple of things here. First of all, our approach is not symbolic. I started off by talking about DARPA's 3 waves of AI. So the third wave of AI is not, sort of redoing of the first wave. So it's not a purely logical approach. That we know that doesn't work. But it's a whole kind of another discussion of where it fits in. Now, of course, a lot of people talk about hybrid systems. Can we combine wave 1 and wave 2, logic systems and so on. But even if we're talking about, cognitive AI, can you combine it with LLMs? No, you can't, because you still cannot update the model. Now, as I mentioned, of course, a cognitive AI can use an LLM as a tool user. And in fact, this is one of the things I'm excited about. A few years ago, one of the big hurdles I saw is, okay, we build this engine that can now learn, but how do we give it all the common sense knowledge it needs to have? That has become a lot more tractable with LLMs, because if you have a reasoning system that can actually validate the knowledge that it's getting from maybe multiple LLMs, cross-checking it with Wikipedia or whatever. So LLMs, I think, are tremendously useful for helping to train an AGI, and they can be used, in tool use. But the technology to combine them, there really isn't. They're not compatible at all. To integrate them, they're not compatible. Again, I'd love to be proven wrong if somebody can show a way of doing incremental learning, of updating of a model of an LLM, will have solved the problem. Are we out of time? All right. Well, thank you.